HighBridge, a division of Recorded Books, presents The Physics of Superheroes. More heroes, more villains, more science. Spectacular Second Edition. By James Kakalios. Read by Kevin T. Collins. Foreword. Although Wile E. Coyote is by no stretch of the imagination a superhero, I have to admit that it was this hapless villain who escaped death episode after episode while continuing to fruitlessly chase the Roadrunner with almost Sisyphean intensity day in and day out, who first got me thinking about the physics of illustrated characters. Even as a relatively young boy hooked on television, I suspected there was something fishy whenever I saw Wile E. run off a cliff and hover indefinitely until the moment he realized there was no solid ground underneath. Somehow it seemed to me even then that gravity should continue to work whether or not one was conscious of it. I bring this example up in spite of the fact that it involves no superheroes, and in fact involves a television cartoon rather than a comic book figure, because it illustrates a point that has become central to the way I think about teaching physics. Few things are more memorable than confronting one's own misconceptions. Indeed, some of us who study physics education for a living suggest that it is only by directly encouraging students to run up against their own misconceptions that you can help them internalize what you're teaching them. I don't know whether this is true or not, but I do know that if you want to reach out to understand popular misconceptions, then exploiting where we get our cultural perspectives from is a good place to start. And if that means borrowing from Superman or Star Trek, I am all for it. Now, I don't want you to think that I bring up comic books and popular misconceptions in the same paragraph because I want to denigrate the former. Far from it. Indeed, the comics sometimes actually get it right, and as James Kakalios describes in his introduction to this far-reaching journey from the gravity of Krypton to the quantum mechanics of the X-Men, students often seem to grumble about how the standard examples from his introductory physics class have nothing to do with the real world they will encounter upon graduation. But when they are instead introduced to the physics of superheroes, this complaint never arises. One might initially wonder whether Superman might seem more real to students than pulleys, ropes, and inclined planes. But the real reason students don't complain is undoubtedly that the comic book examples are fun, while inclined planes aren't. And that is perhaps one of the most useful reasons for thinking about the physics of superheroes. Not only can you imagine and be introduced to lots of interesting physics, from everyday phenomena to esoteric modern subjects, but it is actually fun to think about. Moreover, while subjects like quantum mechanics might seem intimidating, who could be intimidated by cute kitty pride? Some who remember the comic books that enthralled them as young people might also recall a sense of wistfulness in pondering whether our own world could ever capture the excitement and drama of the worlds of comic book superheroes. In truth, however, it is far more interesting and exciting to open up our minds to the hidden wonders of nature that science has revealed to us over the past 400 or so years. Truth is far stranger than fiction, even comic book fiction, and finding out why is all part of the fun. Lawrence M. Krauss, Cleveland, Ohio. Preface. I was a comic book fan as a kid, but like many who have come before and after me, I abandoned the hobby in high school upon discovering girls. My mother, following the standard script, used this opportunity to throw my collection away. I renewed my comic book reading habit years later in graduate school as a way to relieve the stress of working on my dissertation. Now, as an adult, I've rebuilt much of my comic book collection, or, as my wife refers to it, the fire hazard, but as a precaution, my mother is not allowed near it. Back in 1998, the University of Minnesota, where I am a physics professor, introduced a new type of class termed freshman seminars. These are small, seminar-type classes open to entering students, and while they are for credit, they are not tied to any particular curriculum. Professors are encouraged to develop classes on unconventional topics, and freshman seminars on bioethics and the human genome, the color red, a chemistry class, trade and the global economy, and complex systems, from sand piles to Wall Street, are among the many offered. In 2001, I introduced a class originally entitled Everything I Know About Physics I Learned from Reading Comic Books. This is an actual physics class, covering most of the topics traditionally covered in an introductory course, but rather than employing illustrations of masses on springs or blocks sliding down inclined planes, all of the examples came from the four-color adventures of costumed superheroes, and focused in particular on those situations where the comic books got their physics right. The present book, while inspired by this class, is not a textbook per se. It is written for the non-specialist who is interested in a relatively pain-free way to learn about the basic physics concepts underlying our modern technological lifestyle. Topics such as forces and motion, conservation of energy, thermodynamics, electricity and magnetism, quantum mechanics, solid-state physics, and materials science are discussed, and real-world applications such as automobile airbags, transistors, and microwave ovens are explained. I hope you will be so busy enjoying this superhero ice cream sundae that you won't realize that I am sneakily getting you to eat your spinach at the same time. This book is intended for both long-time comic book fans and those who can't tell Batman from Man-Bat. In order to describe the physics connected with certain superheroes or storylines, I have had to summarize key plot points in various comic books. Therefore, for those who have not yet read these classics, the following 2 words apply to this entire book. Spoiler alert. Readers interested in consulting the source materials considered here will find citations of the comic books discussed in the text at the end of the book. I have listed the original comic book information and, whenever possible, where the issue can be found in a reprint volume. The dates listed for a given comic book printed on its cover are not when the issue first appeared on the newsstands. To extend shelf life, the date listed indicated when the comic was to be returned to the publisher for credit, and not when it became available for purchase. In an effort to attract new readers who desire first issues as collector's items, comic books will occasionally restart their numbering scheme while keeping the name of the comic unchanged. If not otherwise noted, issue numbers refer to the first volume of a comic. I have listed, where known, the writer and artist for each comic listed in the endnotes. My omission of the inkers should not be construed as denigrating their contribution to the finished comic. I most certainly do not believe that such a job is equivalent to tracing, but rather a reflection of the fact that the artist, along with the writer, typically have the primary responsibility for the physics in a given comic book scene. Any discussion of physics in comic books naturally invites the scrutiny of physicists as well as comic book fans, both of whom are known for their, let us say, attention to detail. Each of the incidents I've selected illustrates a particular physics principle. Sometimes the very next issue would contain a scene contradicting the physically plausible manifestation of a superpower described here. When considering characters that have starred in multiple comic books for more than half a century, it is a sure bet that there will be counter-examples for any statement I make. Consequently, while examining the physics associated with a superhero's powers will, in many cases, provide a better appreciation for their talents, my comrades in fandom are advised that this book is not intended to provide definitive accounts of any character's power or adventures. Similarly, my physics colleagues are warned that this book is for a non-expert audience. I have attempted to keep things simple while acknowledging the rough edges and complications of the real world. A complete discussion of many of the topics considered here could easily expand to fill several volumes and would provide a concrete illustration of Dr. Manhattan's final words at the conclusion of Alan Moore's and Dave Gibbons' Watchmen. Nothing ends, Adrian. Nothing ever ends. The language that describes the physical world is mathematical in nature. Why this should be so is a deep philosophical question. The physicist Eugene Wigner referred to the unreasonable effectiveness of mathematics in accounting for nature's properties that has puzzled and stirred all those who have studied it. It is tempting, in a book involving comic book superheroes, to avoid even the slightest whiff of mathematics. However, that would be a cheat, worse than omitting any reproductions of artwork in a book about Picasso, or not providing a CD of recordings for a book about the history of jazz, because mathematics is necessary in any thorough discussion of physics. One may protest that they do not understand math, or cannot think mathematically. But for this book, all that is required is that one recognizes that 1/2 plus 1/2 equals 1. That's it, that 2 halves equal a whole. If you are comfortable with 1/2 plus 1/2 equals 1, then writing it as 2 times 1/2 equals 2/2 equals 1, that is, 2 multiplied by 1/2, should cause no concern, because obviously 2 halves equal 1. It seems so simple that you may be surprised to discover that we have already been doing algebra, and you thought you'd never use that again after high school. As many students have long suspected, there is a trick to algebra, and the trick is the following. If one has an equation describing a true statement, such as 1 equals 1, then one can add, subtract, multiply, or divide, excepting division by 0, the equation by any number we wish, and as long as we do it to both the left and right sides of the equation, the correctness of the equation is unchanged. So if we add 2 to both sides of 1 equals 1, we obtain 1 plus 2 equals 1 plus 2, or 3 equals 3, which is still a true statement. Dividing both sides of 1 equals 1 by 2 gives us 1/2 equals 1/2. Since 1 equals 1, then 1/2 plus 1/2 equals 1, which in turn can be written as 2/2 equals 1. I'll make a deal with you. I won't use any mathematics more sophisticated than what's described in this paragraph if you'll refrain from panicking when a mathematical equation appears. You can always glide right by the math, and your understanding will be no worse for it. But if you take a notion to calculate a velocity or a force for a situation other than considered here, you'll have the tools to do so. In any event, I promise you that there will be no quizzes at the end of the book. Preface to the second edition. In graduate school, as the writing of my physics dissertation neared completion, my thesis advisor impressed upon me that no scientific research is ever finished. Regardless of the answers you have obtained to your problem, there are always at least a few open questions, loose threads waiting to be pulled. Having written The Physics of Superheroes, I have discovered that, similarly, no book is ever finished. The manuscript is delivered to the editor, galley proofs are checked, though the typographical errors that inevitably slip through are guaranteed to be the first thing the proud author spots upon cracking open the newly published book. The book shows up on the shelves of bookstores, and yet threads remain loose. There is always more that could be said, or said better. Consequently, I was pleased when Gotham Books offered me the opportunity to revise Superheroes for a second edition. The feedback I received from readers on the 2005 first edition suggested many topics that warranted additional attention. My estimation of the time Superman would spend pushing his weight down against the ground as he prepared to leap a tall building in a single bound, in particular, provoked many friendly discussions with readers, and I am happy to have a chance to elaborate on this point in this second edition. Additionally, soon after publication, I came across superhero illustrations of various physics principles that, had I been aware of earlier, I certainly would have included. This second edition also includes new chapters on fluid mechanics, angular momentum, and materials science, as reflected in discussions of the heroes and villains Aquaman, the Top, and Whirlwind, and the entire Justice League of America and Avengers, respectively. Some chapters in the mechanics section have been reordered in order to improve the flow of the topics discussed. Every chapter has been edited, some extensively. Moreover, mathematical analysis indicates that in this second edition, the jokes are now 12.7% cornier, in some cases by the utilization of the anti-rule of three, 2 punchlines followed by a straight line. I hope that you will find this second edition to be a fun and accessible way to learn the basic principles of physics. In addition to all of those I thanked in the first edition, there are a few new names whose assistance with the second edition I wish to acknowledge. Patrick Mulligan at Gotham Books has been a wonderful and insightful editor of this edition. I am proud to thank my son Thomas for his careful reading of the new chapters and his suggestions for improvement and clarification. Laura Jovag, who runs the unofficial Aquaman website, and Rob Kelly at the Aquaman Shrine website were both great resources for all things Aquaman related, and provided indispensable information and images of the aquatic ace. I appreciate their generous time and effort. Once again, Jenny Allen's assistance preparing the new figures for the second edition is greatly appreciated. Introduction. Secret Origins: How Science Saved Superhero Comic Books. If I had ever wondered whether or not my students found studying physics to be a waste of time, all doubt was removed several years ago. I was returning from lunch to the physics building at my university when I overheard 2 students as they were leaving. From their expressions and the snippet of conversation I caught, it seemed that they had just had a graded exam returned to them. I'll quote here what I heard, but in the interest of decorum, I'll clean it up. The taller student complained to his friend, "I'm going to bleeping buy low and bleeping sell high. I don't need to know about no bleeping balls thrown off no bleeping cliffs." There are 3 nuggets of wisdom contained in this statement. 1. the secret to financial success. 2, as scholars of English grammar can attest, bleeping can be both an adjective and an adverb. And 3, that the examples used in traditional physics classes strike many students as divorced from their everyday concerns. The real world is a complicated place. In order to provide illustrations in a physics lesson that emphasize only a single concept, such as Newton's second law of motion or the principle of conservation of energy, physics teachers have developed over the decades an arsenal of overly stylized scenarios involving projectile motion, weights on pulleys, or oscillating masses on springs. These situations seem so artificial that students inevitably lament, "When am I ever going to use this stuff in my real life?" One trick I've hit upon in teaching physics involves using examples culled from superhero comic books that correctly illustrate various applications of physics principles. Interestingly enough, whenever I cite examples from superhero comic books in a lecture, my students never wonder when they will use this information in their real life. Apparently, they all have plans, post-graduation, that involve protecting the city from all threats while wearing spandex. As a law-abiding citizen, this notion fills me with a great sense of security, knowing, as I do, how many of my scientist colleagues could charitably be termed mad. I first made the connection between comic books and college education back in 1965, when, for the princely sum of 12 cents, I purchased Action Comics number 333, which featured the adventures of Superman. While not a huge fan of the Man of Steel at the time, I was seduced by the comic's cover, which promised a glimpse into the inner workings of our institutions of higher learning. As a kid, I was deeply curious as to what college life would be like. Now that I am a university professor, I realize that this was a premonition that once I entered college, I would never get out, and that my matriculation would turn into some sort of life sentence. A story in Action number 333, titled Superman's Super Boo-Boos, featured a scene in which, as a tribute to all he's done for humanity, Superman was to be granted an honorary degree of Doctor of Super Science by Metropolis Engineering College. I should point out that such a degree option was not offered when I enrolled in graduate school. On the cover of this issue, Superman was in a large auditorium on a college campus and was writing his name on a bronze honor scroll using his heat vision. The aged faculty in attendance, wearing commencement dress, were aghast, not due to the fact that searing beams of energy were emanating from Superman's eyes, but rather because the professors saw a fire-breathing dragon up on the stage instead of Superman, due to an illusion cast by Superman's arch-nemesis, Lex Luthor. This was part of Luthor's scheme to constantly confound Superman's expectations until he was paralyzed by indecision and hence unable to stop Luthor's evil schemes. Even as a grade school kid, I realized that this depiction of college life was probably not too realistic. Nevertheless, the cover did provide two insights that, in the fullness of time, have turned out to be fairly accurate. The first is that all college professors, at all times, always wear caps and gowns. The second is that all college professors are 800-year-old white men. While this may have been my first indication that comic books and college could coexist, it would not be my last. Over the years, I have continued to enjoy reading and collecting comic books. This is not a guilty pleasure of mine, simply because I don't believe in guilty pleasures. Snobbery is just the public face of insecurity. And in my reading I've noted that the writers and artists creating superhero comic book stories get their science right more times than you might expect. Those not overly familiar with superhero comic books may be surprised to learn that anything in comic books could be scientifically correct, and one can learn a lot of science from reading comic books. The big superstars at National Comics, which later became Detective Comics and is today known as DC Comics, are Superman, Batman, and Robin, and each issue of World's Finest contained a team-up adventure of the Man of Steel and the dynamic duo. In this story, a crook, Victor Danning, has his intelligence accidentally increased to genius level during a botched attempt to steal a brain amplifier machine. Using his enhanced mental powers, he proceeds to commit a series of super crimes, drawing the attention of Batman and Robin and Superman. After several of his schemes are narrowly foiled by our heroes, Danning decides to take a proactive approach and attempts to discover the hidden headquarters of Batman and Robin, the Batcave. It's not really explained how this would defeat Batman and Robin, and it is presented as a given that if you are a crook, you want to learn the Batcave's address. Danning instructs his henchmen to plant sticks of dynamite along the perimeter of Gotham City. Monitoring the resulting shock waves on his radar seismograph, Danning explains that the waves traveling through a cave will have different speeds than those moving through solid rock, and in this way the location of the Batcave can be discerned. In this example, the evil genius Victor Danning is on solid scientific ground, for it is indeed true that the velocity of sound, or a shock wave, will depend on the density of the material through which it moves. Sound waves need a medium in which to propagate. In a dilute medium, such as air, there are large spaces between molecules, which makes it harder for pressure waves to propagate, compared with water, steel, or the thin walls of an apartment. Roughly speaking, the denser the medium, the faster the sound travels, which is why in old Western movies a character would put his ears to the railroad tracks to determine whether a train too distant to see was approaching. He could hear the train's vibrations through the steel rail much sooner than if he waited for the same noise to reach him through the air. Indeed, geologists make use of this variation of the speed of sound waves in order to locate underground pockets of oil or natural gas. The depiction in comic books of actual scientists and how they work, on the other hand, often leaves much to be desired. In the very same issue of World's Finest, the inventor of the brain amplifier, Dr. John Carr, describes his latest experiment at a scientific conference. He boasts that his device will increase any man's mental power 100 times. Unfortunately, Carr points out that there's one catch, saying, "There's one ingredient that's still missing before his machine will work, and I haven't found out yet what it is." This is equivalent to inventing a machine that turns lead into gold or tap water into gasoline, but needs one key element, and who knows if it even exists, to work. Rarely are presentations made at physics conferences of work in such an unfinished state, at least not intentionally. Watching this presentation is Victor Danning. This is where he was inspired to steal the brain amplifier despite its intrinsic design flaw, who is labeled in the caption box as a crooked ex-scientist. This part rings true, for I speak not just as a physicist, but for all scientists when I say that once you become crooked, we kick you out of the club and strip you of your scientist title, ripping the epaulets off your lab coat and tossing you to the curb. The incorporation of scientific principles into
Sample complete. Ready to continue?